in this exercise we have this nice continuous function, and we must find its local extrema subject to this constraint. We can manipulate this into y equals x plus 2, and now we must write this back into our function. We will have f of x and y equal to f of x and x plus 2, which is x squared plus 4x plus 2x times x plus 2 squared. We can simplify this. X squared plus 4x plus 2x times x squared plus 4x plus 4, and we have 2x cubed plus 1 plus 8x squared, that is 9x squared, and 4 plus 8x, that is 12x. Now this is a smooth continuous function of the single variable x, so we denote this by g of x, where the variable x has no constraints. Now we will use the second derivative test to find its local extrema. We must first calculate g prime, which we will get 6x squared plus 18x plus 12, and as next step we must find its critical points by solving the equation g prime of x equals 0. By writing the formula into the equation, we get 6x squared plus 18x plus 12 equals 0, and by factoring 6 we get 6x squared plus 3x plus 2 equals to 0, which is clearly 6 times x plus 2 times x plus 1 equals to 0. Now we have found the critical points, which are x equals negative 2 and x equals negative 1. Now we must calculate the second derivative of g, which will be 12 times x plus 18, and now we find the value of the second derivative at the critical points. So first let's consider the critical point negative 2. We have negative 24 plus 18, which is negative 6, which is smaller than 0. So here we have at x equals negative 2 a local maximum place. And now we must find the local maximum at that point, so we must substitute into the function g negative 2. So g at negative 2 will be, that is negative 16 plus 36 minus 24, which is negative 4 as the local maximum value. And now we must consider the other critical point, 2, negative 1. So the second derivative, negative 1, will be minus 12 plus 18, that is plus 6, which is greater than 0. So we know that at x equals negative 1, we have a local minimum place. And now we must calculate the local minimum value. So we substitute negative 1 into g, by which we will get negative 2 plus 9 minus 12, which is negative 5 for the local minimum value